So calcium. Somebody throw out a polyatomic ion. Your favorite one. Huh? Polyatomic ion. That's on the upper right-hand corner of your sheet.
Nitrate.
Nitrate. Okay. So calcium nitrate. All right. So nitrate has a NO3 1 minus. Like this is the happy family nitrate, and it's got a 1 minus charge overall. What is calcium's charge? You guys should have your periodic table in front of you, probably for the rest of your life. Okay. 2 plus because it's in group what? Group 2, it loses 2 electrons. Okay. So then as you go through your crisscross rule, you're taking the 2 down low and the 1 down low. So then you get calcium 1, which you don't write because the 1 just looks silly, and then the nitrate in parentheses, as you've already done, and then what goes on the outside? 2. Okay, so that is calcium nitrate. Calcium nitrate requires 1 calcium 2 plus ion to balance out how many nitrate ions? How many nitrate ions do I have in this formula? 2 of them. That subscript says I have 2 nitrate ions. And that makes sense. 1 calcium ion balances out 2 nitrate ions because what's the overall charge of 1 calcium ion? Overall. What's the charge on this baby? 2 plus. What's the charge on 2 nitrate ions? 2 minus, right? Because 2 times, so a -1 plus a -1 is a -2. So 2 plus and a 2 minus equal 0. So the reason that we have to have different subscripts, you know, the whole crisscross rules, because they're electrically neutral. They always balance each other out in terms of their charges. So I need 1 calcium for every 2 nitrates to do that. And that's just how it always works out. Like, you never have to verify this, but this is just the reason behind this crisscross rule. So let's do another metal and non-metal. So I'll go magnesium 2 plus, because magnesium is our group 2 metal. And let's go bromide. Magnesium bromide. Bromide, that "ide" ending, indicates to you that it's something straight from the periodic table. Okay, that's usually straight from the periodic table. What's the charge of bromine?
3 plus.
Bromine is what?
Oh no, this one.
What is it?
Not right. 1 1.
1 minus, because it's in the 7th group, gains 1 electron to be like a noble gas, right? Gaining 1 electron means you get a negative charge. All right, so these crisscross, and you get, what's the overall formula? MgBr2, right, because this 2 goes out to the outside of bromine. All right, so this means I need 1 magnesium for every 2 bromines to make it overall neutral. Now, this one right here is just simply magnesium and bromine, so 2 types of elements. What kind of ionic compound is that? If it's just 2 types of elements. My people who were here yesterday should know this. I, right. This is called binary ionic, because it's ionic. How in the heck do I know it's ionic? Metal, non-metal, and it's got charges, right? Ionic or ions, they have charges. And it's binary because there's only 2 types of elements. So a magnesium type and a bromine type. That's how I get BI, binary ionic. That's on your problem set, so I just want to make sure you guys got that. This one is still ionic, right? Calcium nitrate. How do you know it's ionic? What's the first thing you see? A metal, right? It's not technically a metal and a non-metal. It's a metal and a polyatomic ion. So that's how you know it's ionic, because it's got ions in it. So ions are always present in ionic compounds. This one, though, has calcium, nitrogen, and oxygen involved. So not binary. What is this one called? Ternary. Thank you. I don't know who got that. So T for ternary. Ternary just means I got more than 2 types of elements. That's all that means. Anytime you have a polyatomic ion involved, it's going to be ternary, because they already make up 2, and ions always bond with something else. So that's what will always work out. Polyatomics will be ternary compounds. Okay, let's do another one like we did yesterday, but let's use a transition metal. So somebody give me a transition metal from those of you who were here yesterday. Iron. Okay, iron what, Abby?
Iron 2.
All right, so this is like, first name is iron, middle name is 2. Okay, so this is iron 2 that she's speaking of. This is on the video. The transition metals always have to be described a little bit more, because transition metals have transitional charges. They're not just straight up, 1, 2, 3, 4, -3, -2, -1. They have some additional information. So iron is going to be a +2 charge. What's another option for iron who was here yesterday? Plus 3. It could be iron 2 or iron 3. So you have to tell somebody that because we can't read your mind. You have to literally say it. So this is iron 2. Let's do iron 2 sulfide. Iron 2 sulfide. What did I tell you the "ide" ending meant? Periodic table. So who am I talking about for this one? Sulfur. What's sulfur's charge? 2 minus, right? Okay, so this gets crisscrossed down here. So what do you get in the first place when you crisscross these? Iron 2s2, correct? Because there's 2 and 2. That looks like we can reduce it. If you can see 2 different subscripts that are on the outsides of the ions, and you see that they're the same, you always reduce down to the lowest possible ratio. So what's the lowest possible ratio? 1 and 1, right? So this is iron 2 sulfide. But if you see this, you don't see the 2s, right? So you have to kind of go backwards in your mind going, how did I get here? So let's try that. If I gave you this FES and you had to name it, like aka like write out the name, the first thing you would see is iron. So you got that much. But then you would say, oh, this is a transition metal. I have to write a Roman numeral, like I did here, to tell somebody the charge because we don't always know it. So then you have to figure out the charge that we indicate in a parentheses right here. All right, so then you go, all right, well, this is a 1 and this is a 1. Backtrack. So it looks like that's iron 1 plus, and it looks like that's sulfur 1 minus. But then you go check your periodic table. Can sulfur have a 1 minus charge? Absolutely not. It's not in the halogen group. It's not in 7A. So that means, all right, so whoever wrote this FES stuff, they've already reduced. So they reduced from what, though? This previously was S2 minus. This previously had to then been Fe2 plus because I reduced them in the same amounts. So that's how you get to say, oh, okay, so this is iron 2, and then you just name the last name of it, which is sulfide. All right, is this one binary ionic or ternary? Binary ionic, right. We see 2 types of elements, iron and sulfur. That's it. 2 types of elements, iron and sulfur. So this one's just BI, binary ionic. Okay, so we did ionic with polyatomics with transition metals, just normal. Let's do covalent. One of you here who were here yesterday, throw me out your favorite covalent compound.
Sulfur trioxide.
Okay, we'll go sulfur trioxide. I didn't do anything. I didn't write down charges. I just went straight to the chase. How was I able to do that so quickly?
Because you knew it was 3 oxygens by the tri.
Right. So in covalent compounds, it's non-metal. There are no charges involved. Heck, you don't even have to look at the periodic table unless you forget what a symbol is. You know, like for example, chlorine. You're like, oh, I can't remember what chlorine is. You know, if you just have a brain fart. So sulfur trioxide. If I say carbon tetrachloride, what's tetra mean?
3.
Tetra means 4, right. So carbon tetrachloride. Carbon, carbon. Tetra means 4, right? But 4 of what? Chlorines, right. 4 chlorines. All right, I say carbon dioxide. You hear me saying carbon, so you write carbon. Dioxide? 2 oxygens, right. O2. So the prefixes are, mono means 1. Tell me the next one. Di, tri, tetra, penta, hexa, hepta, octa, nona, deca, dodeca. Okay, and this is on your note sheet too. There's a little box that's got the covalent prefixes in it. But covalents are really easy because you don't have any tricky like crisscross rules and stuff like that. Okay, so we're going to review acids and organic today, and then those of you who need to catch up from yesterday, you'll have some time to do so. Let's roll. Ready? Ready. Oh, this is before we start. I forgot to tell you this yesterday. You will start to see things that look like they're little mini-me's. They're twins, and they have to stick to each other. These are called diatomic molecules. You have to know these. So write down these diatomic molecules. What is this diatomic molecule thing telling you about the molecule? Two what? 2 just atoms. So this diatomic means 2 atoms. And these are always 2 of the same atoms. So I've got 2 H's, 2 O's, 2 N's, 2 F's, 2 Cl's, 2 Br's, and 2 I2's. And I'll scroll down again in just a second. And so there's an easy way to remember the 7 diatomic molecules. I'm just going to cross out now because we rarely see that. So the 7 diatomic molecules look like a big 7 on the periodic table. Plus hydrogen. Hydrogen does not follow anybody's rules. It's just like this rogue element that's going to hang out in the upper right hand or left hand corner, okay? So doesn't that look like a big 7? So I call the diatomic molecules the big 7 plus hydrogen. That's how you're going to remember which ones are diatomic. So pretty much what this means is if you ever have to write something all by its lonesome, if you have to write F by itself, not bound up in an ionic compound, not with another molecule, F does not do well by itself. Fluorine is not a single guy, okay? It likes to have 2 people together, 2 molecules together, or sorry, 2 atoms together, and that makes a molecule of fluorine. Same thing with chlorine. You don't ever write chlorine just by its lonesome. If you're writing just chlorine, and that's what you're going to leave me, that's wrong. You have to write chlorine diatomically. This is not like in a covalent, not in a covalent or in a ionic compound though. This is just like if you have to write it by itself. And we're going to get to some examples with this. Nitrogen doesn't exist by itself, like by its lonesome. It exists with little mini me. Those are called diatomic. So that's just an extra piece of information you guys had to know. What's up? There was one ATs down here, but we don't ever use it. Iodine was the last one. We never see AT as a diatomic molecule, so I just ignore that one. It's radioactive. It's not really all that much used. So AT's down here. Okay, so let's do acid. I'm going to skip this one right now. Okay, so write down this page. So if you want to reference this in your textbook, you have access to it. This is the page where you'll see the acid nomenclature rules. So we are going to eventually be really comfortable with ionic, covalent, acid, and acids are really similar to ionic. Okay, they just have some different rules. And then organic, and that's our last bit of nomenclature. And we'll practice this some more maybe tomorrow. Okay, so page 272 is where you're going to find these rules. And you actually did some of this stuff already in your reading guide. We heard about eights and icks and ites and oses in our reading guide. So this will actually help clarify that. So I'll be quiet. You guys write down some stuff and I'll do some examples. Okay, so we'll do some of these examples together. Before I touch acids, all in here, I want to review our suffixes that we've seen over and over and over again. The most common suffix you see on any of these names, the names are going to be first name, last name, like sodium chloride. Is that ionic or covalent? Sodium chloride. Ionic, so it starts with a metal. But you heard me say "ide" at the end, okay? Then I say carbon dioxide. I end with "ide" again. But what is carbon dioxide, ionic or covalent? Covalent. So "ide" doesn't really tell you anything. It tells you it's either ionic or covalent, but generally the "ide" ending is going to mean it's binary. It's either binary ionic or binary covalent. The way we denoted that on our problem set is that binary ionic was Bi, binary covalent is BM. That means binary molecular. Molecular is the same thing as covalent. That's the only reason we put M there. So identing tells you it's binary. It's just two different elements. We got some subscripts in there though, so you just have to know your charges or listen to your prefixes like di, tri, tetra, penta, blah, blah, blah. Okay, if you see an H or an I ending, that is going to be a polyatomic ion. So if it's a polyatomic ion, it's definitely an ionic compound. Okay, so you'll see phosphate, nitrate, chlorate, bromate, carbonate. Yeah, more. Okay, so you're gonna hear all these eights. You also hear phosphite, nitrite, sulfite, chlorite, all these I endings. They're just a variation. Okay. Now, those of you who were here yesterday, you already know the trick. So if I say, for example, phosphate, PO4 3- is phosphate. You already have, you're soon to have your eights memorized, your phosphates, sulfates, anything that ends in H as a polyatomic ion, you should have up here, okay? But then if I say, oh, well, what's phosphite? I'm not trying to trick you. You know a trend. What is the trend for this? You lose a what? You lose an oxygen, okay? Lose an oxygen means instead of being PO4 3- for phosphate, phosphite is PO3 3-. I just drop an O. You can do that for anything. Nitrate, NO3 1-. Nitrite, NO2 1-. Okay, so once you know the eights fall right into place. All right, so that's this review of the suffixes that kind of you'll start to get the hang of and kind of they'll fall in place. Okay, those are really important to acid nomenclature. So until you feel really comfortable with your polyatomics, acid's going to be like you need to start referring to your polyatomics more often than you want to. Acid nomenclature always has an H in it. If you ever see an H and then something else, it is an acid. That's really easy to recognize if it's an acid or not. You probably saw some of those in your problem set 9s already, and you're like, I don't know what this is. Okay, you can have two types of acids, binary acids or ternary acids. Binary acids mean what? Two what? Binary means two types of elements, okay? So, hydrochloric acid, HCl. HCl has two types of elements. Hydrosulfuric acid, H2S, has two types of elements. Hydrophosphoric acid has two types of elements. But where are these numbers coming from? I'm not just throwing numbers up there. Where do you think they're coming from? Like, where do you think this 2 came from? The what? The charge of sulfur, right? This is H plus. H is a first group, right? These act ionic. So I'll say this up here: ionic / acid nomenclature. They act ionic. They have charges. So H has a 1+ charge because it's in group 1. Sulfur has a 2- charge because it's in group 6. Yeah, so it's 2 away from noble gases, so it's got a 6, or it's in group 6. So when you crisscross these, you get H2S. So how did I get this 3 here? From the P's charge, right? So this was H plus, and this was P3- because that's phosphate or phosphorus. It's in the 5th group, so it's got to travel 3 electrons to be noble gas. So let's not get the 3 down here. It's just crisscrossing. So this is acid, but the thing is, it's actually easier because you always know the first element. What is it? H. Okay, so that makes it easier. Now you heard me say hydrochloric, hydrosulfuric, hydrophosphate, hydrophosphic acid. What was common that you were hearing? Hydro. Okay, so this hydro that you see does not mean H. Okay, because if I say acid, you already know H, so I don't have to say acid and hydro to mean H. The hydro means it's binary. That hydro should indicate to you binary. So you think simple. You think H bonded with one other element, one type of other element. Okay, so if I say HCl, the best example, that's hydrochloric acid. It's just you take the ending of whatever your nonmetal is and you just put "ic" on it. So if I want you to name that. Hydrobromic. It's, you got to go "ic" on the end, so it sounds weird, but it's hydroiodic. Hydroiodic instead of hydroiodine. Take the ion off and put "ic" on there. Okay. HF, hydrofluoric. Sorry, that's H3N. Hydronitric. So you're just saying hydro. Now, why are you saying hydro again? Because it's not because it's always first element. It's because it's binary. Hydro does not say H. I know it sounds like it should H. It should indicate there's an H there, but it's an acid. It's always going to have H there. You don't got to tell me. I know, okay? You just have to tell me that because I want you to know it's just two elements together. Okay, now if you don't say hydro, I'm going to assume there's more than two elements involved. So I'm going to assume it's ternary. If you don't say hydro, I'm assuming ternary. So ternary acids, you go straight to the chase. You just start naming it with the polyatomic ion that's involved. Because remember, ternary means usually three, maybe four, more than two types of elements. And that's the real reason you don't say hydro. It's because there's more than two types of elements. Now, what's still going to be in the front because it's an acid? H, right? You're still going to have an H, even though you don't say hydro. Hydro means binary, doesn't mean H. You're still going to have an H in the front, and the H is still a +1 charge because it's in the first group and it loses one electron. Then you're going to have a polyatomic ion attached to it. So I'm going to choose my favorite. Let's go sulfate. Okay, so I want to put hydrogen ion and sulfate ion together. So what's my overall formula here? Right, this 2 comes down here to be H2, and that 1 comes down there to be, you know, the one on the outside. I put parentheses to really just help you see that's still sulfate, okay? So this is hydrogen ion together with sulfate ion. The name of that is going to be slightly different because we don't say hydro, we go straight to the chase. So we take our 8, remember we had a suffix of sulfate right here, and we change that to ic acid. So, say again? Sulfuric acid, right. So you don't say sulfate acid. That sounds weird, okay? I don't know if we have to have all these rules to change in the names. I promise I didn't come up with this. This would be madness. But we have to change the name to show that it's sulfate and not sulfite. Okay? So eights go to ic. And then let's do another one just like this, but let's lose an O. So I want you to put hydrogen ion together with sulfite. So what's sulfite? SO3, 2 minus, right? So don't change the charge, I just lose an oxygen, okay? So this is now going to come together to be what? Come together. Okay, so you can see there's a difference. This one is H2SO4, this one's H2SO3. So obviously their names have to be different because they're totally not the same compound. So this one was an ite, and it goes to ose acid whenever you change its name. So this is not sulfite acid, this is sulfurous acid. Okay, so I had some students like 4 years ago now who told me the dumbest way to remember this, and I'm sticking with it because I have not come up with anything better. So you guys know, like, really cheesy stupid ways to remember things, but here's how I remember it. To go from 8 to ic is ic, I ate too much. Oh my gosh. Yeah, stupid, right? Okay. So ic, I ate too much. That's how I remember ic and 8 go together. And then, oh, Miss Dillon, I've got tendinitis. Okay? If you come up with something better, I will use your example for the next decade. But that's all I got. So deal. So I and os go together. So I've got tendinitis. Yeah, that's all we got. That's what we got to work with. Okay, so come up with something better for me. But that's how you remember the acid rules. Ic, I ate too much. Ic and 8 go together, and then itis. I got tendinitis, and it and us go together. So let's practice. Let's do this. This one, actually, I'm gonna go to the ones on your page because I'm not going to make you guys do all the lecture examples. I just give like a plethora of them because I want you to feel comfortable. No, sorry. This one looks like this. It's on the back, I think, of your lecture note page. Of course, you can write these in your notes and do what you got to do, but I left you guys some space there. So let's go with, let's just go first example right here. Nitric acid. Automatically, what do you not see? You don't see hydro, so what do you assume about this? Ternary. Okay, so this is ternary. Ternary means includes or has a polyatomic ion. All right, what polyatomic ion is going with nitric? Nitrate, right. It can go together. So we know nitrate's involved. What's the other thing involved? Hydrogen ion, right. H plus and nitrate go together to make what? Well, tell me the formula. Spell it out for me. HNO3. And I will put parentheses around that because I'm sticking with my guns on the parentheses. So that's nitric acid, HNO3, or you can put parentheses around it like that for the nitrate. All right, let's skip one because I'm gonna need some space here. Let's go to number 3. Polyatomic or binary or ternary? I'm going number 3. Binary or ternary? Ternary, because what do you not see? Hydro. So no hydro means it's ternary. So it means it's got a polyatomic ion. What polyatomic ion is acetic? Acetate. Okay, acetate's formula is C2H3O2 parentheses 1 minus. That's acetate. It's a big one. Okay. What's the other ion here? Hydrogen ion. Okay, crisscross applesauce. What we got here? Just smush them together, right? So C2H3O2. I don't have enough space for this mess. Okay, I'll have to write smaller. So C2H3O2. Looks really big, okay? Let me write that a little bit bigger. All right, so you guys try all the ones that are ternary first, and I'll do some more with you. What's the next ternary one? Sulfurous, number 5, okay? So sulfurous came from sulfite. Okay, what's sulfite? Ite and S go together, right? So what's ite? SO3, parentheses, 2 minus. Okay, and so then put those together, what do you get? H2SO3. Okay, so the polyatomic ions, like I said, you guys are going to start memorizing them, but they start to come naturally because you use them so much. But if you have to look down at your paper for every single question, you want to do a problem set for 2 hours, which should take 30 minutes. That's the value here, because then our next unit, you'll be the boss at this, and you won't take a longer time to get through problems when, I know you guys have a life, you got sports, you got all kinds of stuff going on. You don't want to spend forever doing this, you just have to know your stuff. Let's go down to 12. Hydroiodic acid. What does that automatically tell you? Binary. So we got H with what? Iodine. Okay, so H with iodine. So when you see hydro, you should say, oh, that's binary. So I go automatically to H, and whatever it says, iodic sounds like iodine, kind of. So that's HI, right? Hi. There you go. There we go. Hydroiodic acid. All right, let's choose another binary one. Give me one. What number? 10. So hydrofluoric acid. That's an H plus in what? In what?
Fluorine.
Fluorine with a charge of. Look at your periodic table. 1 minus. So that's just HF put together. Let's do. Yeah.
Well, can we put the transition?
No. Maybe like in a polyatomic ion, but that's about it. So let's do. Oh gosh, I want to do one of these. No, I'm just gonna start. I'll go on this side now. So now we want to go from formula to name. All right. So first thing you see, is this polyatomic or is this binary? Is it ternary or binary for number 16? Ternary. So do you say hydro? Hydro, no. Okay, so you go straight to the name. So ClO4. Who is that? It's actually perchlorate, right? If you look on your, but ClO3 is chlorate. When you have an extra O, it goes +1. So plus, I think of per. All right, so that's perchlorate ion. So how do we change the 8? to ic. There you go. So perchloric acid is how you name that one. No hydro because it's not binary. These are a little harder because you have to know the names of the polyatomic ions. All right, so next one, you see ternary or binary? Ternary. So you have to find the name of the polyatomic ion. What's PO4 3 minus? Because don't forget that 3 goes up to the top. That's phosphate. Change the name. Phosphic. It's actually phosphoric acid. It sounds weird to say phosphoric acid. I don't know why we had to add a little syllable in there every now and then. So this is phosphoric acid. It just sounds better coming out of your mouth. That's really the only reason. Like, why is the periodic table placed like that? Why is there F block below it? Because it would take up 2 pages versus 1 page if we put F block in there. It's the only reason the periodic table has F block below it and not inserted where it should be. It's because somebody was lazy and was like, no, it looks better this way. I'm gonna put this underneath. That's the only reason the periodic table looks like that. Man-made. Okay, this one, binary or ternary? Binary. So what do you say to that? How do you say that? Hydro. Okay, hydro what? Yep, you change chlorine to chloric. There you go. So hydrochloric acid.
What does that say?
Parentheses.
Me
Oh, it says aqueous. It says aqueous. It just means liquid. Liquid and dissolved in water. All right, next one, ternary or binary? Ternary. So you say hydro? No. Okay, so go straight to the chase. SO4 2 minus. Who is that? Sulfate. So it goes to what? Sulfuric. So it sounds like you should say sulfic, like phosphate, but they like to have that second or third syllable in there. Okay, so sulfuric acid. 20. Ternary or binary? Ternary. Who's the polyatomic ion involved? Is it nitrite? Yes, it's nitrite. Okay, so NO3 1 minus is nitrate. Notice there's a NO2 1 minus involved here. That's nitrite. How does I get changed? Oh, okay, tendinitis, right? So instead of saying nitric acid, you say nitrous acid. Try a couple of those. I'll come around. Go through some more. I think the naming ones are, well, go through both. Take 5 minutes. Huh? Next one, yes, it's a 5 minute. Holler if you need me. You guys okay? Questions?
You see this was slightly different.
Huh? All right, take one more minute. Ask me questions if you need to. Yeah, 3 more slides, people. Just wait for me. Okay, so let's do organic, and this is the last bit, guys, okay? Pull out the reference, I'm sorry, not reference sheet. This sheet that you've been working on has a table already, yeah? Already got a table, so you don't have to write much for this, but I do want to show you this and highlight or star, put some stuff where you need to, okay? So, organic nomenclature focuses on what elements? Carbon, right. Organic just means carbon. So if you've got a lot of carbon and a lot of hydrogens are usually involved as well, because carbon really likes to bond with hydrogen, then it's an organic compound. Their nomenclature is slightly similar to what we've been dealing with, but this is something that's really important in combustion reactions. So we have to learn some of this because we have to be able to talk about combustion reactions. So you guys have this table, yes? Suffixes and all. All right, so if you have, let's say, CH4, what that looks like is it looks like this. H bonded, H bonded, H bonded, and H bonded. Because there's C with 4 H's attached to it. Carbon loves to share its electrons because how many valence electrons does it have? Carbon. 4. So carbon loves to form 4 bonds because, hey, it gets to share, 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 share. And if it shares 4 times, it gets a total of octet. So it's got 4 and it shares 4 times, so it gets octet. That's the only reason carbon is commonly found in bonds in the world, okay? So that is called methane. Who's ever heard of methane? All right, did you know CH4 was methane? No? Okay, CH4 is methane. You've heard of it before, but this is methane right here. Well, where in the heck are we getting this whole meth prefix from? It's because if you have one carbon in your substance, you just call it meth, and then you end it with a different suffix than other stuff. And I'll get to that in a second, okay? So if I write another one of these, if I write C2H6, C2H6, how many C's do I have? 2. So I say two C's by saying F. Who's heard of ethane? Ethanol. Ethanol, carbon dioxide and ethanol produced from yeast alcoholic fermentation biology. Yeah? Okay. Ethanol, E, has 2 carbons in it. Let me show you what ethanol looks like. Ethanol looks like C bonded to C, bonded to an OH, and then there's an H up here, H up here, H up here, down low, down low. So it's just 2 carbons attached to each other in a chain. This is looking like biochemistry a little bit from biology. You had like lipids, carbohydrates, proteins, nucleic acids. These are looking more like the lipid ones because they're long carbon chains. Okay? So you say F to indicate 2. Propanol, isopropyl alcohol. Propane tanks? Yeah, propane. How do you know? It's got C3 and an H something. We're going to figure out that something in a second. Who's ever heard of a butane lighter? Yeah, we're going to play with lighters this year. I took the flints out. That was my only requirement. Okay, butane lighters have stuff called butane in it, which has C4H something. We're going to get to that in a second. Pentanol, pentane. What do you think pent means? 5. Okay, so we got 5 carbons, C5H something. Okay, hexanes. Hexanes are really poisonous to you. Don't take hexanes in. Okay, not as often as you should anyway. You probably breathe them in from your car exhaust, but that's okay. So C6H something. Hep means 7. Thanks, guys. Oct means, who's heard of octane? Okay, that octane, whatever, 93, 95, 97 that you put in your car. Okay, that's a really combustible fuel because it's got a lot of bonds. So it's got C8 with a certain number of H's. Okay, now the certain number of H's, you've heard me go octane, you've heard me say pentane, pentene, you've heard me say octene, octane, I'm sorry, ethene, ethane, something, okay? So you'll see the first name, the first part of it, the prefix tells you the number of carbons. The last name, the last part of it, like ane, ene, ein, all, ol, all, means what's attached to it. How many H's are attached to it? If there's something different. So the way you remember it is, if it says ane at the end, that means you take your N number. Your N number is going to be like whatever carbon chain, whatever number of carbons you have, multiply by 2 plus 2. So if I say methane, what's my if I say methane, what's my number for carbon? My number for carbon, meth. 1. Okay, so I take 2 times 1. 1 is my carbon, okay, plus 2. So how many H's do I have? 2 plus 2. 4. I have 4 H's involved in methane. What was my formula for methane? I just wrote it. CH4. CH4. So you don't have to know how this stuff bonds. You just have to be able to tell me how many H's are there. So anytime you have an ane, you just go 2N plus 2. You find whatever the carbon is, times it by 2, and then just add 2. So let me give you another example. Let's do propane. Propane. Think for a second. What does prop mean? Prop means 3. Propane means 3 carbons. How many H's? So you did 3 times 2 plus 2, so that's 6. That's 8. Right, we have 8 H's. Put that together. C3H8. Let's do another one. Let's do octane. Octane, okay? Octane. How many C's? 8. So then I say 8 times 2 plus 2. 16, 18. So CH18. It's not really hard if you can remember that. If you remember that one, you can remember the rest of them. Now, if you have something like ethene, or I'll do it right here because I have a P right here, or a 3. Propene, which is an ene ending, you just do your number of carbons times 2. That's it. That's because there's a double bond in there. So you just do 2N. So if prop means what? Prop means 3. I got 3 carbons. How many H's do I have? 6, because I just say 2 times 3 give me 6 H's. So what's the formula for propene? C what? C3H6. Okay, if you have an alkyne, yne, Y-N-E, it's 2N minus 2. So we had 2N plus 2, 2N, 2N minus 2. It's not tricky, just going down by 2 each time. That's because every time we go down by 2, we actually form a bond in between them, which kind of accounts for that. So we still have octet. We're still happy compounds. We just don't have as many hydrogens surrounding it. So let's do pentyne. Pentyne. How many C's? 5. So C5. How many H's? 8, because 2 times 5 minus 2 is 8. So H, 8. Let's do another ine. Let's do hexyne. Hexyne. How many C's? 6. H's? 10, because you're doing 12 minus 2. Okay, last one is alcohols, and we're not going to have a formula, like, tricky way to do it with the H's. I'm just going to tell you it's got an OL ending. I mean, a OH ending. So alcohols have an OH on the end, so something like ethanol. Ethanol, OL, means that I have an OH sub, I don't want to say suffix because it's on the end of a compound, but it's like C2H5OH. It's just got an OH on the end of it here. We'll do some examples with that, but that'll be like the least used example. We'll use all these other ones up here. So I'll get to another one with that just momentarily. Let's do some practice. Okay, actually, let me do, do I want this one or, no, we'll go back. We'll go here. All right, hexane. What's the hex mean? 6. So, okay, so I got C6 and then ane. How did you get 14? 2 times 6 plus 2, because that means number of H's, so this means number of C's. So 2 times 6 plus 2 is 14, so H, 14. That's propane. Ethanol. Ooh, ethanol is what I just did. F means 2, so we got 2 C's. And then normally what happens is, and I'm going to draw this one for you, normally what happens is these 2 C's are attached to each other in the middle. And then if it was just ethane, if it was ethane, what would the whole shebang be? C2H6, because you would do 2N plus 2 for anes, right? So what happens is these 6 H's are going to surround the carbons so that every carbon has 4 bonds. Every carbon's got 4 bonds, right? 1, 2, 3, 4, happy. 1, 2, 3, 4, happy, because that means it's got octets. Each of those bonds represent 2 electrons. Okay, so if I have an ethanol, that means one of these H's goes away, and we put an OH on it. That's it. So I'm going to erase this one out here, and instead of it being an H on the end, I'm going to put an OH on the end, which is what this all ending means. So how does the formula change here? Yeah, H5OH. So just take off one and add the OH. So I like to draw that one because I can see it better. I can see the subscripts of all of these. All right, propine. 3, so C3, ine. 2N minus 2, right? Because ines, oh, I don't know. Did you guys see this in alphabetical order? Ane, ene, ine. So ane, I don't know. I'm just going to give you my little hints. Ane, ene, ine is alpha order. That one is 2N plus 2. This one was 2N, and this is 2N minus 2. So if you can remember in alpha order, you can remember what each of these things means. I mean, that took me, what, 20 seconds to write out? You can write that out for yourself if you need that reminder. Okay, so ine is what for this one? 2 times 3 minus 2, so 4. H4. Whew, how is that baby drawn? I don't know why I have a 6 there. I just realized that. That's a 3. I was like, why did I get that 6? Okay, I think I was just thinking ahead on something else. Okay, so propine would be drawn like C, C, C. Okay, one of these, this ine means it's got a triple bond someplace. We're going to talk about triple bonds maybe Thursday or Friday. So we're actually going to see this. I'm going to show this now, and then you'll see it again later. Triple bond. Crazy, right? But the triple bond is really strong, okay? This one, this carbon in the middle, how many bonds are around it? 4. It's happy, right? So how many more does this one need to make 4 bonds? 1. So what's attached to it here? An H. Okay, so I got 1 H checked off. How many does this one need? None. How many does this one need? 3. 1, 2, 3. Check, check, check. Our goal is to make carbon have 4 bonds. So sometimes I'll draw them out for you, and if I draw it out, you can get the formula. You can go, oh yeah, that's 3C or 3 C's and that's 4 H's. You can get the formula from a drawing too. And then if I give you that, if you write this out, you would have to be able to tell me that 3 means pro, and that 2 and minus 2 over here for the H's means I. So from a formula, you want to get pro-pi. Alrighty? Alright, so that's all I'm going to do for Orgo now, okay? You'll see very little Orgo. You'll see a lot of covalent and a lot of ionic. 10% of the time you'll see acids, okay? So that's it for nomenclature. So here's what I want you to do. The people who, and actually I'll give you guys a choice. People who were here yesterday, you can stay up here, do problem set 9, you can help other people. For those of you who weren't here yesterday, you need to watch the video from yesterday, which is on my website, on ionic and covalent. Okay, you're already halfway, three-quarters of the way there. You just need a review. Okay, so I'll be up here for help for anybody. If you want to do the precipitates lab, I'll give you extra credit. The precipitate lab is just a practice lab that's based on ionic nomenclature. This is for people who were here yesterday because I appreciate you doing something either helpful or for yourself that's above and beyond just problem set 9. So the rules for precipitate lab are up here. You guys can read. I'll help you if you need it. Okay, this is all man for himself at this point. Go for it. Problem set 9, lab, watch video. Pull out your phone, pull out your earphones. Yeah. If you feel good about it, you have no questions for me, you can do that. Okay?